So, very finally, we've just got to do a conclusion. There's no writing a conclusion or evaluation or anything in the lab diary. That's not what they're for. It's about collecting the data and just doing the processing of it, which includes getting an answer and getting the error in that answer. But there's just a little bit of finishing up what we need to do at the end. So basically, this is summarised usually in a comparison. So let's take a look at how we do a comparison. This is just something that's specific to this one, but it's quite common if you are looking up or trying to experimentally determine a value that's an accepted value. So, for example, in the pendulum experiment, we do this right at the end. If we just look at the example. So right down at the end. Oh, I'm asking a bit much of it there. Hang on. There we go. So, right at the very end, we've got an error in our value of g and we've quoted it. You'll notice in this case, what I've actually done is I worked out both the plus and the minus, and I got different values, so you can write that as a slightly different way of writing errors. You can do a different plus and minus value, as I've done there, 9.76 plus 0.8, but minus 0.2. So you can kind of do that way if you want. So to finish off, what we've done is a bit of a comment. Literally, it's just this last section. So if I just scroll, that is it. That's the comparison. It's tiny. It's just a case of doing a bit of a comment on what the difference is to an accepted value. Okay, so we've got 9.81 to compare to. So what we do is we do the percentage difference. Now notice I've used the original, the accepted value on the bottom, 9.81, not mine, because it'll give you a different percentage difference. I want to know the difference between mine and the proper accepted. So that gives me a percentage difference. Now what I can do is compare that to the percentage error. Now I've got two, okay, so this is a bit more tricky to compare, but you'll just have the one. And you know, this is 8.2% out or 2% out. Does basically, what we've got to decide is, how big was my error? So comment on it. If it's more than 5%, it's not great. How different is it to the accepted value? Okay? Compare those two. If the percentage error and the percentage is bigger than the percentage difference, then it means effectively that you are right. You might have a large error, but the real answer is within your range of answers somewhere. Okay, that's the kind of comparison you want to make. So within the range of answers that our 9.76 plus or minus 0.8 plus 0.8 and minus 0.2 covers, 9.81 is in there. So it is close to the real answer. But you can then comment on how big is the percentage difference, is it significant? How big is the percentage error? So the sort of average error here was 5.1%, which is a bit over 5%, so it's not brilliant, but it's not horrendous. Just some sort of comment like that. Now, the only thing that you will have to do in addition to this, which doesn't appear in this example here, just using it as 9.81, is you will need in your comparison to also do a reference. So you'll need to look up your data and reference it. So what am I seeing? I'm seeing a comment on size of... Now, although you give your final answer in an absolute error, it's a good idea to comment on the size of the percentage. More than 5, bad. Less than 5 is okay. Quote a researched value. So you'll need to look up what the resistivity of your metal was. So quote a researched value. We need the reference. This is a marking point. Alright, you won't hit full marks on this if you don't reference your information. So you need to put a reference in there for that. Just one, just fine. Just put a value. You might find some people use strange units. Please don't try and compare yours to somebody else who uses a different unit. Look for something that's in gigapascals, or at least it's in pascals, and you can convert it and do a comparison. Comment on the difference. So is it close? Does the accepted value lie within your range of repeats? Is it only 3% difference to yours, but your error is 5%? In which case, yeah, it lies within inside. Look at the absolute errors. Look at where your actual value falls, and within that range, let me get this right, within the range, so your value is in the middle plus or minus some, does the accepted value fall within that range? Don't worry if it doesn't, but don't pretend that everything's okay if it's actually way out. If you're, by this point, if you're a factor of, like, 10 out, maybe there's a bit of an issue. Maybe not. There might be lots of errors in the experiment, but maybe there's an issue. If you're a factor of hundreds or thousands out, go back and check your data. Okay, because the chances are you've misconverted something somewhere, or you've missed a decimal point when you've worked something out or something. But make sure that you do comment on the size of your percentage error, I should say. Quote a researched value and compare it. So, comment on the percentage difference between the accepted and yours. So, comment on percentage difference. So obviously you've got to work out percentage difference. Meaningful comment. Not essay, but meaningful comment. And put a reference in for that value. And that, ladies and gentlemen, is your lab diary done. It's a lot of work. So the quicker you get on with it, the better you'll be. Cool. Good luck with it. If you've got questions and things, get in touch. But all the information you need is there. Use the example and use the notes. That's what they're there for. There's a lot of them, but there's a lot of work to do. So make sure you make use of them as you go. If you're completely floundering at any point, give me a shout and I'll give you a point in the right direction.